When you first wrote l.append, you met a brand new piece of syntax, the dot. It looks strange right now, but that little dot hides one of the most important ideas in Python. Let's decode what dot notation really means and then use it to build lists from scratch. Here's the key idea. Everything in Python is an object. Every object carries two things: data, the stuff that makes it up, and behaviors, the things you can do with it. That's why the operations differ by type. What you can do with an integer isn't what you can do with a string, and neither matches what you can do with a list. The available behaviors depend on the type of the object, and at its core, essentially everything in Python can be written using dot notation. Familiar shorthands, like the plus operator or the length function, are really just convenient disguises for operations that could be written with a dot. So how do we read dot notation? Take l.append. To the left of the dot is the object, the thing you want to operate on. Here, that's a list named L, but it could just as easily be employees or words or any list. Then comes the dot. And to the right of the dot is the operation you want to perform. Now cover up the L and the dot. What's left looks exactly like a function call. A name, append, followed by parentheses and arguments. So the operation is really just a function that runs on the object before the dot, and its arguments are what you handed, here the item to add to the end of the list. Let's use append to build a list. We want a function, makeOrderedList, that takes a positive integer n and returns every integer from 0 up to and including n in order. So makeOrderedList of 6 should give 0, 1, 2, 3, 4, 5, 6. Here's the pattern. First, create an empty list. Don't name it list, because list is already the name of the type. Anything that changes color in your editor is off limits. Call it my list instead. Next, loop with the loop variable I over range from 0 to n plus 1. Why n plus 1? Because range stops just before its upper bound, and we need to include n itself. Each time through, I takes the next value, 0, then 1, then 2, and so on, and we append I to my list. When the loop finishes, we return my list. Watch it fill. It starts empty, then grows to 0, 1, 2, 3, 4, 5, 6. One small note, the 0 inside range is optional since range starts at 0 by default, so range of n plus 1 on its own works just as well. Now a filter, write remove lm, which takes a list L and the value e. It could be an integer, a string, whatever you want. It returns a new list holding the same elements in the same order, but with every element equal to e taken out. Same recipe. Start with a new empty list. This time, loop over the elements of L directly. One caution, naming the loop variable, I here would be misleading because that letter usually signals an index. But this variable holds the element itself, so we call it element. For each element, if it is not equal to e, we keep it by appending it to the new list. Otherwise, we skip it. At the end, we return the new list. Let's trace it with the list 1, 2, 2, 2, 2, and e equal to 2. 1 is not equal to 2, so 1 is kept. Every 2 is equal to e, so all of them are skipped. The result is a new list containing just a single element 1. Let's test a few more cases on the same list. 1, 2, 2, 2, 2. Remove 2 and we get a new list with just 1, exactly as before. Remove 1 instead, and all 4 2's survive. We get 2, 2, 2, 2. Now remove 0, a value that never appears in the list at all. Nothing matches, so the whole list comes back unchanged. One last point worth stressing. E is a single element, an object like the number 5. It is not a list. If E were itself a list, we will be searching for that exact list as one single element sitting inside L, which is a completely different question. 2 patterns, 1 shape. To build a list, start empty, loop. Append each item you want and return it. To filter a list, do exactly the same, but append only the items that pass a test. And underneath both sits dot notation, the object on the left, the operation on the right. For now, just remember which functions use the dot. Soon, when you build your own object types, that dot will be everywhere. To practice what you just learned, this course has free exercises and AI graded feedback on Ludium.ai. The link is in the description.